Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, and welcome all to this session. My name is Andrea Manara from the ITU, the International Telecommunication Union. It is an honor for me to introduce this finale event for the 2022 GeoAI Challenge. You may know that ITU has been hosting a successful machine learning and 5G competition for a few years already. This year, we decided to launch the GeoAI competition alongside the GeoAI Discovery webinar series, which provides a forum for leading voices in the fields of geospatial and AI across various sectors to describe latest research and real application of GeoAI to meet the Sustainable Development Goals. We discussed several topics like digital twins, agriculture, climate, health, ecology, ethics, and we held a few workshops on analyzing deforestation with machine learning and the Google Earth engine. The recordings of all GeoAI webinars are available on YouTube. The ITU GeoAI Challenge aims to provide a platform for collaboratively addressing real-world geospatial problems by applying artificial intelligence, machine learning to advance the United Nations Sustainable Development Goals, SDG. Participation is open to any individual from one of the 193 member states of the ITU. ITU provides also a state-of-the-art, free-of-charge compute platform to participants of the challenge who do not have adequate access to compute in their respective institutions. Within the ITU GeoAI Challenge, the goal of Cropland mapping with satellite imagery problem statement is to encourage the development of accurate, cost-effective classification model for cropland extent and crop intensity maps using machine learning and artificial intelligence technique. Those maps are essential to many applications in agriculture, as well as other relevant disciplines, such as natural resources, environment, health, and sustainability. We had 47 participants and 36 equipes who enrolled to this competition, but finally only one team was able to submit a solution. So we really wish to thank and congratulate the MJ team for such an accomplishment. We will start this session with the introductory remarks by one of the co-chair of the UN Open JS initiative. So I will invite either Kyung-Soo Eom or Maria Brovelli to switch. Kyung-Soo, excellent. Welcome to this session. So Kyung-Soo has been serving as chief of the UN Geospatial Information Session since 2005 in the United Nations. The UN Geospatial Information Section supports geospatial information needs of the Security Council and the UN Secretariat, including UN field missions, and oversee global GIS programs at UN headquarters and in the UN field missions. So I'll give you the floor to Kyung-Soo to give an overview of the UN OpenJS initiatives. Thank you very much.
Thank you so much, Andrea. I like to actually share my screen if I can. Are you able to see?
Yes.
Thank you. Thank you. I think I am going to actually put that Yes, presentation mode. Yes, thank you very much. I'm the one of the co-chair, but on behalf of the co-chair of the UN OpenGIS, Professor Kijun Lee and Professor Maria Brovelli and myself. And I'd like to actually give you a very brief kind of the introduction of the what is the UN OpenGIS. The United Nations has the mandate for supporting to maintaining international peace and security, and also to promote economic and social development, as well as to promote and protect the human rights. So there are many different kinds of the peacekeeping and political operation for peace, and then also sustainable development goal is one of the important agenda for the United Nations. And does UN Geospatial wanting to be provide all universal use of the geospatial information to underpin and support all mandate of the mandate and operation of the United Nations for a better world. This is our aim from the geospatial perspective, and during the various aspects of the UN issue that we are facing, many different kind of challenging in terms of the disaster and peacekeeping, and also human rights issue, and protection of the civilian, and so on and so forth. So those are the kind of the mandate that what we're supposed to be provided, and so that in the time of the crisis, we must provide a certain kind of the geospatial information and suitable GIS tool for making better decision and effective operation. So these are our aim. In that regard, we see that a lot of the challenges that we don't actually have a sufficient kind of the tools and solution to solving the problem. So in that aspect, we like to actually identify and develop open source GIS bundle that can be meet the UN operation, and in cooperation and collaboration with the member state, as well as the academia and international community and voluntary community, and so on and so forth. Why we are doing that? Because of the many of the challenges and limitation and constraint. So we try to build up the more flexible, scalable, and more effective way to provide support to the UN operation in general, and then also partner organization. We have a vision, UN OpenGIS has a vision to promote, advocate, and mainstream hybrid geospatial technology for enhancing UN operational capability, as well as that for supporting developing countries' geospatial capacity building. These are the aim. And then we also like to actually build up the hybrid GIS platform, regardless of various different kind of the source of the tool. We are able to provide the maximum access to the most suitable GIS solution to the geospatial expert. That's the hybrid system, and we have 6 the working group the established. Each of the working group actually focusing to actually developing, enhancing, improving all of the open source geospatial technology and solution. Thank you very much for your kind attention. Thank you. Over to you, Andrea.
Yeah, I thank you very much, Kyung-Soo, for this very nice introduction. And then I would like to invite Sonchin Chen to the floor. Here you are, to deliver the introductory remarks for this GeoAI crop mapping competition. Sonchin is a senior IT officer at the Digitalization Informatics Division at United Nations Food and Agriculture Organization. He's now leading the development and operation of FAO hand-in-hand initiative Geospatial platform, agricultural applications of cutting-edge technologies, including artificial intelligence and geospatial IT. And he is also one of the co-chair of the GeoAI working group of the UN OpenGIS initiative. So Jean, the floor is yours.
Thank you, Analia. Good afternoon, good evening, good morning, everybody. I'm very glad to join this event. After a long journey of almost a whole year, today we have the final event of the first GeoAI challenge on crop mapping with satellite remote imageries. Congratulations and to everyone who contributed and participated in this challenge. Thank you, everybody, indeed. As you know, remote sensing is an ideal tool to collect information rapidly and economically for agriculture. Crop mapping is fundamental to many agricultural applications, including crop management, food safety, animal production, global change, economy and trade, and also UN SDGs. I just named some of them. In UN OpenGIS GeoAI working group, we planned a series of GeoAI challenges. This crop mapping is the first of this series. In the plan, we also have planned to start GeoAI benchmarking for different fields. So we started this challenge at the end of June, about half a year ago. Time passed very, very quickly. So just as Andrea introduced, we have 36 teams registered, but we have only one team submit their final result. But we don't lower the standard. So we finish all the process for evaluation, and we think you have excellent work. Okay, congratulations. This challenge is the first one. It is not easy with planning, organizing, and implementation. During the past year, we have strong support from our collaborators and partners. I'd like to thank you all who made this happen. Firstly, my great thanks to Malia with Polytechnic Milano, who initiated the original idea and continues to support the challenge. And also, I want to thank Mr. Kyung Soo-young and Jung Tang with UN OpenGIS. Your assistance support is critical for this event. And also, great thanks to ITU colleagues. You provide the platform organizing the whole event. Special thanks to Andrea, Thomas, Reinhard, and our other ITU colleagues. And we also want to thank IFU internal collaborators. We were not working from the same the single division. We have data contribution from land, soil, and water division, and also other colleagues working for this challenge. The last but not least, I thank you all the participants who are interested in and join this competition, this challenge, and thank you all. That's it. So this just as I said, this is the first one. We will continue this challenge. Thank you, Andrea. Back to you.
And I thank you very much, Georgina. And now is the time for the DMJ team. So I invite you to switch on your camera and to make your presentation. We are really looking forward from hearing from you, and good luck for your presentation.
Thank you so much. All right, Dirk, could you please go to the first slide? All right. So hello, everyone. My name is Javeria, and I'm an undergraduate senior student majoring in computer engineering and minoring in data science at the American University of Sharjah in UAE. And today I'm here with my team members, Dia, Maya, and Mohammed. And I would appreciate if you guys could please go ahead and introduce yourselves. Dia, would you go first, please?
Hello, everyone. My name is Dia Abuhani. I'm also majoring in computer engineering and minoring in both data science and computer science at the American University of Sharjah. And moving on to Maya.
Hi, my name is Maya, and I'm also a senior student at the American University of Sharjah, and I'm also majoring in computer engineering. Moving on to Muhammad.
Hello, everyone. This is Muhammad Al-Muhandis. I'm also majoring in computer engineering and minoring in mechatronics at the American University of Sharjah. And that's it. Yeah, you can start the presentation.
All right. Thank you so much, guys. Thank you so much for the introductions. And I would also like to thank everyone here for giving us this opportunity today to present our solutions on this platform. And without further ado, we'll get right into our presentation. So moving on. All right. So we'll be proceeding with our presentation in the following manner. We'll first talk about our data collection methods, and then we'll give a brief insight into how we pre-processed our data to be fed into our models. And then we'll talk about the models that we use for our cropland extent and intensity problems. And then finally, we'll wrap up our presentation with the best accuracy results and just all our model results in general, and the possible future work from this point onwards. Moving on with Mohandas.
Okay, so for the crop land extent, which is the first problem we were working on, we had, of course, the 4 countries, Sudan, Iran, Mozambique, and Sri Lanka. We collected a total of 150 samples from each country. And these samples were split into 2. In case of the cropland extent, we did 75 for crop samples and 75 for non-crop samples. And the reason we went with 150 was to be able to go with lower than 500 samples, which was the competition requirement, as well as have the model be able to train and have good results. And also, as you can see here, that Sudan, Iran, and Sri Lanka, they have a good spread of samples. But for Mozambique, you can see it's not scattered that much because Mozambique, the area that we were working on, did not have a lot of crops, and the crops were just located in the areas where they were the samples are currently located in the image. Also, in Sudan, it was the easiest to find crops because Sudan was full of crop areas. But when it came to Sri Lanka, for example, it was difficult to also find samples because some places were forests, and we had to manually decide if it's a crop or not, and we had to see if it's a forest or not. And if it's a forest, we decided to go with non-crop. And also when taking the samples, as you can see, this is this is like just an example. You can see the gray point shows the river, so this is a non-crop, and you can see the orange parts are the crop areas. It can either be grown or not grown, so we took both as crop and we labeled them as crop. Okay, moving on to the pre-processing part.
So when it comes to the time series, as you can see here, these data, the time series that were provided covered a half month. However, we noticed that there were some areas with missing values, with some gaps. So for example, here, this is an example where you can see that this whole time series for this specific instant have values of 0, which means it is missing. Henceforth, we decided to have some NDVI reconstruction methods. What we decided to go with is to first look at these points where there are missing values. For example, these 2 values indicates that there are some missing values. So what we did is basically at the beginning, we used this Swiatkowski-Golay smoothener to smoothen our time series. Then we performed linear interpolation on these specific points by just taking the average of the point right before it or the right after it. If the difference between these 2 points exceeds 4,000 in NDVI score, which is the half of the maximum. If you look here, you can see the NDVI time series after reconstruction, where the missing values got replaced with a new value that fills the gaps that were there in the initial one. Now, if you look at the results here after running our machine learning models, for example, the orange area here represents the cropland, where the gray ones represent the non-cropland. If we zoom then, for example, this is Sudan, and you know that the Nile River is in Sudan. So if you traced it, here you can see the Nile River obviously here, and it is labeled as non-cropland, where the other areas were cropland. Now moving on to intensity.
Okay, so when it comes to crop intensity mapping, we first collected our data set by handpicking polygons of cropland and non-cropland from Google Earth Engine. By doing so, we made sure to collect a considerable amount of cropland data specifically in order to get a representative data set that covers all 3 cropland classes. Now, we explicitly chose to collect our data through polygons instead of Google Earth Engine markers in order to get as much data as we possibly could. This is because after our first trial with data collection and then labeling, it became apparent to us that the 3 crop cycle class specifically was being underrepresented in all countries. And this is obviously due to fields that have 3 crop cycle crops being less common than those with 2 crop cycle crops or 1 crop cycle crops, or due to 3 crop cycle crops not being grown as much in fields. Now, another thing we made sure of during data collection was to collect non-cropland data that encompasses a wide variety of non-cropland areas. Hence, our non-cropland data includes residential areas, forests, and most importantly, bodies of water. Now, I stress on bodies of water specifically because they came to be a trouble area in all countries, and particularly in Mozambique, where certain regions of the river were being classified as cropland when we underrepresented the river in the non-cropland class. So we presume that happened because these regions contained algae and freshwater plants, which were driving the NDVI values up as opposed to the expected low and negative values. So after finishing our data collection, if you can move the slide. After finishing data collection, we exported the concatenated feature collections as CSV files to Google Colab. Thereafter, we ran our time series data through a Savitsky-Golay filter in order to smoothen the curves. Then we applied a linear interpolation method in order to rid our time series of missing values. And finally, the last step in this pipeline is to label the training data set. Now, as we found that crop intensity mapping was difficult to accurately assess through visual interpretation, we developed our own labeling algorithm, which we used to count the number of cycles in each and every time series, and then label the data accordingly. So the algorithm goes as follows. First, we traverse over a given time series and detect the maximum NDVI value present. Afterwards, we create 2 thresholds based on this value. One threshold is for thresholding peak values, and another is for thresholding value values. The peak threshold was made to be 70% of the absolute maximum in the series, whereas the value threshold was made to be 20% of the maximum value in most cases. After detecting both critical values, we traverse through our time series and then count the number of peaks and valleys based on the thresholds that we assumed. We then only assume that there is a crop cycle in the time series when we find a peak value that is encompassed between 2 valley values. Using this algorithm, we were able to label our training data set to our best of abilities. And most importantly, we were able to do so while avoiding counting spurious peak in our data as crop cycles, which is a common problem in crop intensity mapping, as we have come to uncover through our literature review. And then afterwards, moving on, after labeling the data, we just reduced the size of the data set as to comply with the rules of the competition. And then we started training our classifiers. And as you can see here, these are the results of running the classifiers on Google Earth Engine.
Now, moving on to the final results of different models. For Cropland extent, we tried 4 different models: random forest, XGBoost, LSTM, and bidirectional LSTM. For Mozambique, you can see that in most cases, XGBoost performed the best with relative results to LSTM. They both have the same accuracy. For Sudan, XGBoost again performed very well. For Iran, well, the results were almost all very relatively close, which shows some linearity. However, bidirectional LSTM seemed to outperform every other model. For Sri Lanka, LSTM and XGBoost were also very well. Now for crop intensity, Julia.
All right, so for the crop intensity problem, the models that we deployed were the random forest, the XGBoost, and the K nearest neighbors algorithm, along with the dynamic time warping algorithm. So the random forest and XGBoost models were used since these are usually the more reliable machine learning classification models that are generally used for classification problems. Random forest especially performs usually well, even with missing data or data that has noise, and it still gives reasonable results despite all of that. It also usually prevents data from overfitting as well. So this is one of the reasons why we chose random forest as our model of choice. The XGBoost model uses gradient boosting algorithm, which also usually produces optimal performance as well. Now, the one algorithm that we used specifically in intensity that we didn't feel the need of using in Cropland extent is the K nearest neighbors algorithm coupled with the dynamic time warping algorithm. The dynamic time warping algorithm essentially finds the optimum alignment between two sequences of observations. And since intensity is a problem that uses time series sequences, we deployed the dynamic time warping algorithm. So this algorithm is quite convenient as well, since it does temporal dimensional warping as opposed to Euclidean warping, which makes it good for classifying sequences which have different frequencies or that are out of phase, or even if they're not of the same length, the algorithm will still work just fine. So the shortest path between the two sequences in consideration are computed, and hence the most optimal alignment and the value that we find from this point on is passed on to the K nearest neighbors machine learning algorithm, which then acts as a classifier and classifies it into the 4 different classes or the categories that we have over here. So that's one of the reasons why we specifically used this model over here, because we're dealing with sequences of data and it works really well with classification of sequences. Now, one point to note over here is that the results, Alia, could you please? Thank you. So one point here to note is that the accuracy results from Mozambique for all the 3 models actually comparatively is not that high. And we're assuming that might be because of the fact that the river part in Mozambique had algae or maybe freshwater plants that caused the NDVI values to go high, as Maya mentioned earlier. So that's one thing to note. We can see that the highest accuracy result that we got is 95%, and that's in Sri Lanka using the random forest model. And following that, we have 92% accuracy that we got in Mozambique and Sudan using the XGBoost and the dynamic time warping algorithm respectively. And then we had the 80.3% highest accuracy in Iran using random forest and XGBoost. And again, we can note here that the results for crop intensity is not as high as compared to the cropland extent problem. And again, that's a little expected because we are not dealing with a binary classification here. We have 4 categories. So consequently, the performance would be a little lower as compared to a binary problem. And that's about it for the results. Moving on.
Okay.
Yes,
can you hear me? Okay. So for the crop, for the last part of the competition, we were supposed to export them into a GeoTIFF format. So the way we did this was using the GDAL library. So first we read the raster data into the Google Earth, Google Colab, and then we went over each line and iterated over each line, and then we ran the model, which was random forest, and then we saved it back as a GeoTIFF, and we viewed it on the Google Google Earth Engine. So the way we did this was using some functions. For example, we had to make sure that the image size remains the same. So once we read the data, we also saved the image size, we saved the coordinates. So once we were done with running the model on the raster data, we were able to construct the image or the image back into a GeoTIFF format, and then we were able to view it on a Google Earth Engine. So, okay, so to summarize our work, we first collected samples from Google Earth Engine, and then we pre-processed the images in order to have a smooth NDVI time series. And then we were able to run machine learning and deep learning models on the NDVI time series and then we did it for both the crop extent and the crop intensity problems. Now, for the future work, we are looking forward to or like we are thinking of doing more areas, maybe trying different machine learning models. We also think that the data collection was a little bit difficult, and it also affected the results a bit. So if we have more reliable ground truth data, that would definitely help in improving the results. And also try to work with different number of samples and try to compare what is the most optimum number of samples for this specific problem to give us the most accurate results. And that's it from our side. Thank you everyone for listening, and looking forward to answering your questions.
I thank you very much for your intervention. It was really an excellent presentations, very well organized and very, very well explained. So really very big congratulations from my side. I'd like to ask my colleagues if they have any questions, and then we will move to the award ceremony. I'd like to ask a question. Did you have previous experience in crop mapping, crop intensity analysis, and more generally in geospatial satellite analysis?
Well, when we first tackled the problem, we had zero experience. We had to do a good number of literature to understand what is going on. That took us some time, so we decided to spend at least a few weeks to understand the problem before proceeding on.
Excellent. Thank you very much. I give the floor to Maria Brovelli, who has switched on the camera and has a question.
Yes, for a question and also a comment. So you understood that I'm a professor, and so being a professor, I needed to make questions. But before my question, I want to underline a very important point, because you said one of the most difficult part or boring part of long part was the training, collecting the training. Be aware, because this is the problem always. Always this is the problem with machine learning, because then when we have, if we have a good training data and possibly also testing data good, and then at this point it's just a matter of running different models, many models. That is definitely the easiest part. But the point related to the data and having reliable training data is really one of the most important points. And so we wanted really to provide an exercise that was what happens in reality when you have to deal with a problem like this one. So what I have to do, the people of FAO, that I want to thank here, Sonshin and Pengju, because they were the people behind this challenge, preparing everything. What they have to do really, in reality, if they want to obtain some results, they have to do that, also searching for the training data. And so this is pretty normal. But I have a question for you. You correctly tried the different models and so on. I wanted to ask, you didn't consider using ensemble models because there was no time, or what is the reason why you considered the different models, but in some way you didn't take into account the possibility of putting them together, try to have something more complex from that point of view? I believe that probably there was not enough time for doing that.
Actually, yes. When we joined the competition, we joined like 2 months after the announcement. So we had to finish in around 10 days. So we were struggling a little bit. And even after it was extended, the semester started. So we didn't have the time to attempt any of that. But yeah, we'll definitely consider it, because we believe that these results can be rapidly improved.
Yeah. Even if the results are pretty good. as a matter of fact.
Yeah.
So by now the results seems to be pretty good. But okay, from my experience, I see that when we are going towards some ensemble models, we obtain something which is also better than the best results that you obtained. Okay, thank you so much. That was my only question and comment.
Thank you.
I have another question. How did you hear about the competition?
We mentioned earlier that we are one senior team and we are working on our senior project, and it is in the field of agriculture. And we had an advisor which received your email and was like, you know, guys, this is a good first shot for you. Try and attempt it. And yeah, so we are here.
Excellent, excellent. I thank you very much. So I think that now is the time of announcing the winner of this competition. There is going to be a big surprise. I will ask the rollouts of drums to make the right atmosphere. I'm joking, I cannot make that, but let me share the screen. Let me share my screen. And then, are you seeing my screen with
yes,
the award? Excellent, excellent. So in addition to a certificate and the one which you will receive will have each of your name written out. We are pleased to give you a prize of 1,000 Swiss francs, and we will get back in touch for all the needed details. So it's really, I think that you did really an excellent job, and I saw that it was also a learning process, and I think that is really an example for future competitions. And again, big congratulations from my side and from all of us. And we would like to make actually a picture with you, and so I will ask also Kyun-Soo and the colleagues from FAO to switch on the camera so that we can make a picture all together with the prize.
I don't know really if we are able of considering both the certificate and the people. Probably we have to remove the certificate if we want to have all the people in visible on the screen.
No, let me see. There should be maybe a way. Yeah. Okay, so we make a picture without the certificate. Okay, so let me stop sharing. So
yes.
Take a picture, and then maybe we make a picture only with the certificate and the winner. Yeah. And I think that it's gonna be good. So smile. Cheers. Excellent. Now maybe we can switch off the screen except the winners, and then we can make another picture with the certificate. Let me switch off also my screen. Let me just increase here. And I don't have everything. I have some technical difficulties in finding a picture which can. I have 3 of you, but I don't have 4. Wait.
And there I have it.
You have it? You did
I
it?
have it. Yes, the only point is that there is also our name. There are not our faces, but there are also Maria Brovelli on one side and Andrea Manà on the other side. I don't know how to
We
remove
cannot
us.
do anything. We cannot do anything
Yes.
about that, I think. Okay, excellent. So now I will say that we need to go to the next part of the agenda. And so the plans for next year competitions, and I hope that you, Joaria, Maya, Dia, and Mohammed will be able and will be interested in participating again. I will also ask Maria, Zonjin, Kyung-Soo, and you to switch on the camera, because this should be an actual discussion and outlook. We have also been hearing the experience of the team which had submitted a solution. So this can be really a model for the future, because we understand that undergraduate student, senior, but may really be interested in being involved in this kind of event, and in the scope of the UN Open GIS initiatives. Also, we can plan additional events like this. So I just give the floor to Maria, and then we can have discussions on this.
Okay, so thank you, Andrea. So after congratulating again with the winners and thanking again Sonxing, Pengju, and Kyung-Soo for, and you obviously, all the people of ITU for the support to this initiative, I believe that we have to organize something similar also next year for sure. This is something that will become more and more important in next year. There is this interesting initiative you were speaking, which is the AI for Good, which will be in July next year in person, because generally in the last years this event was organized remotely, but then you told us that next year, and this is also a good could be of interest also of the senior, and sorry, every time you say senior, I'm smiling because you are young, very, very super young senior. So it could be that also the senior students can be interested in attending this event, which is AI for Good. And in this AI for Good, we will for sure present also something related to the to geospatial AI for Good. And the idea is also to organize some workshops and something like that. So with respect to that, as the participation to this event will be free of charge. Do you confirm it, Andrea? Is it free of charge?
Absolutely.
Yes, it is free of charge. Obviously, you have to find the money for going to Switzerland, because this event will be in Switzerland. But I believe that if you are interested, for instance, in proposing a practical activity where you can show to the other people how to compute your solution and so on, this would be a good idea as part of one of the workshops that we want to organize. So it's up to you to decide if you want to accept also this challenge or not. Anyway, speaking about, so in preparation of also of that event, as a UN OpenGIS working group 5, I believe that we will go ahead rethinking to these challenges in such a way to make it a bit easier, or probably with different levels of difficulty. And but I believe that it is important to go ahead, even if I have done a few. So Sonshin and Pengju, they were the people working really for this challenge. So I want also to listen from them what they think that is better to do, and if they want to go ahead also next year.
Thank you, Maria. Definitely, you know, we have one big plan for this series for GeoAI challenge. So we will continue. Although we only have one team, just now, Adelia asked the question. I really think they are very good example. So it fulfill our objective for this. We will not just collect innovative ideas. We try to promote AI application in geospatial. They're a wonderful example. They're very frank. They told us they know nothing about geospatial, but they learn very quickly. That's a wonderful example. This is fulfill our objective to promote GeoAI in a wider community. And also, I have an idea. We next year we continue this challenge, and if they agree, if the team agree, so we will invite them to present during our starting ceremony, inauguration of the next challenge. Let them share their experiences and their inspiration, and that's something can be quite good. So we can discuss with the team when the time is there. I just stop here.
Yes.
Thank you very much. It's an excellent idea, right? And what I want to mention in parallel is that we had also some other problems in this 2022 competition. We had the GeoAI competition on location mention recognition, for which we had 4 submissions, and we had the final event beginning of this week on Monday, and also that is a competition that was hosted by the University of Qatar and Qatar Computing Center, and they are also interested in submitting a competition also for next year. And then in addition, I'm also looking, because the ITU is the International Telecommunication Union. So which is the leading UN agency for ICT. So we are very much interested for this GeoAI competition in finding applications of GeoAI for the development of ITC applications, systems, infrastructure. So we are also looking forward for identifying that applications. And so I'm looking forward for discussing with all of you all necessary initiatives to build up the challenge in all different aspects. Maria?
No, Sonshin wants to say something, I see.
Yes, I saw the hand, right, sorry.
Okay, and Leah, don't forget, you are the co-chair of a GeoAI working group.
Yeah, I know.
we have the plan for this series of GeoAI challenges, not only for agriculture. And the last time, Chung had the excellent idea to use AI, so use GeoAI for the intelligence information. So we can also maybe in 2023 we don't have one, we maybe have two or more for the GeoAI challenge. So based on our experiences. Okay, I'll stop here.
Maria? Yeah.
Yes, yes, and it's just a proposal because, as a matter of fact, you understood that we are part of an initiative that is a larger one, which was introduced by Mr. Kyung-So-Hom, who is the main chair of this initiative, which is UN OpenGIS. And Sonshin and Andrea and I, and Peng Yu as well, are part of one working group of this initiative, which is related to geospatial information applied, sorry, artificial intelligence applied to geospatial information data. And in principle, this initiative is based on volunteer basis, and there are people like me, professor, there are people of FAO, there are people of ITU, there are people of other agencies of United Nations, and there are also other people, external people, but in principle, we are very open. And so even if you are students, you are very welcome if you want to participate to these events. We have one meeting every month, and we organize what to do, like, for instance, organizing this challenge or organizing some dissemination event about something like a workshop about one specific theme of interest of geospatial information and machine learning and so on. So every month we have a meeting and we propose something. In principle, this can be open really also to you. So if you are interested, simply write to us and we will put you in the list of the invited people for all the meetings we have. It's generally we have 1 hour meeting a month, and generally it is the last Wednesday of the month between 2 and 3 p.m. Central Europe time. So it's a time which is good also for you, as a matter of fact. So if you are interested and you want to contribute to that work package, helping us also for organizing this event in July and so on, you are very, very welcome. And this is my first point. The second point is just if you have some suggestions besides saying, yes, the training data were a bit tough to be collected, if you have other suggestions to us with respect to the challenge.
First, thank you for the invitation. We highly appreciate it, and we will definitely consider joining when we have the time, for sure. When it comes to the challenge, it was nice. One thing that was a little bit problematic is the timing, because I believe it was announced in the summer break, and it's a break, so we didn't get to know about it until so late. I also think that if it is communicated to the universities, they will be very much interested in communicating that to the students, and actually we can even host the challenges inside our universities. We are actually even open. If you want, we can do that. If you have a challenge, just come to us, and we can also give you professors' names and stuff that will let you communicate with our professors right away and make the challenge in our university, as you did in Qatar University.
Yeah, this is a very good suggestion as well. So if you have, I mean, in this case, I think that is your university which has a problem to solve, and that it makes the so-called problem statement. So we have a form, a template, like which is the available data, what you want to solve. You make a description of a baseline model and so on and so forth. And then I think that is something that we can also consider also in cooperation with the Open UN GIS network as well. So as we did with the FAO, they submitted a proposal within the scope of this network. So it could be a way to go. We are really very much interested in hearing
likewise
proposal.
Okay, so fantastic. At this point, I will ask the Kyung-So, the chair, if he agrees with this possibility of inviting these senior students to the meeting of our working group. And also in these meetings, you can come if your professors are interested in coming and discussing also with us possible challenges. I believe that the only limitation is that the challenge has to be of interest of United Nations, or in general sustainable development goals, something related to that, obviously. But this is we don't need to say, obviously, this is the what stays in the background. But I want to ask Kyung-So, what do you think, Kyung-So? No, you are muted.
Thank you very much. That's a brilliant idea. I'm definitely sure that this is a great idea, that we can actually invite those senior professionals to join that GeoAI working group, to work with us. And as many of you are well aware, as what you already been presented as well, that we are facing various different kind of challenges, and not only crop issue and food security issue, but also humanitarian perspective, peace operation perspective, and disaster issue, and so on and so forth. So, and also climate change as well. So many challenges that we are facing with. You may actually be feeling comfortable to join our activity, because we are dealing with those challenges, how we can actually find a good, innovative technology to solve the problem. So we really wish to actually invite you to join our working group. And then I think I'm really looking forward that you can actually be, doing very active kind of, activity and contribution from your very senior professional perspective. Okay. Welcome to join our working group. Thank you.
So I thank you very much. Is 5 o'clock Geneva time. It's really the end of this session. And again, I wish to congratulate you again for the excellent work and the excellent presentation as well. It was really a pleasure to meet you, and I hope to remain in touch, and that you would be involved in future competitions, being like a little bit the champions of this competition. And so I thank you very much all for the participation. I thank also the audience. And now I give back the floor to Anna, our avatar for the end of the session, so we can switch off all of our cameras, and I wish you a very nice weekend. Bye-bye.
Bye-bye. Congratulations.
Bye-bye. Bye.
Bye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for Good.